In today's video, we're gonna look at the basics of a wave, including how to label different parts, how to calculate the wave speed, and the differences between longitudinal and transverse wave. The first thing to understand about wave is that they transfer energy and information from one place to another, but they don't transfer any matter. Waves transfer energy and information from one place to another. But you must remember that they don't transfer any matter. They don't transfer any matter. A wave is basically a disturbance and can be represented in the displacement distance graph, whereby on the y-axis we have displacement and then on the x-axis we have a distance. We can represent it on the displacement distance graph. And the top part is called the crest. The bottom part is called the trough. And the distance from the rest position to the crest is called the amplitude. It's also the distance from the rest position to the trough. Distance here is called the amplitude. Another important factor to look at is the wavelength, which is the distance between crest of one wave to crest of another wave. If we have two waves, this is the first one, this is the second wave. If we have two waves and the distance between crest to crest is called the wavelength, is equal to the distance between trough to trough, is called the wavelength. Wavelength can also be found between one wave. If we have one wave and the distance from the starting point of a wave to the end point is called the wavelength. And the symbol for wavelength, it's lambda. This is the symbol for wavelength, is called lambda. This is the symbol for wavelength. Sometimes you might find that instead of displacement distance graph, you find a displacement time graph, which look pretty the same like this displacement distance graph, but on the x-axis, instead of distance, we have a time on the x-axis. This is here it's displacement. Instead of distance, here we have time. Because we have time on the x-axis, distance from the starting point to the end point is not wavelength. It's called the period of a wave. Distance from here to here is called the period of the wave, which we can find between crest to crest and between trough to trough. Is also the period of a wave. What are the benefits of knowing the period of a wave? If we know the period of a wave, we can find the frequency of a wave by using this formula, frequency is equals to 1 over period, whereby f is frequency and t is period of a wave. But maybe you are asking, what is the frequency? Basically, frequency describes how many waves are passing per second. A frequency is a calculation of how many waves are passing per second. If we have one wave per second, then we say we have 1 hertz, because hertz is the SI unit for frequency. If we have 2 waves passing per second, then we say we have 2 hertz. If we have 30 waves passing per second, therefore waves per second, then we say we have 30 hertz. If we have 500 waves passing per second, then we say we have 500 hertz. The next equation to know is that of the wave speed. That is the most important equation to know, whereby we say that velocity of a wave, of speed of a wave, is equals to frequency of a wave times by the wavelength of the wave, where v is the velocity and f is the frequency, and lambda is the wavelength of the frequency. Basically, but we are multiplying how long each wave by how many are they per second. That gives us the velocity of a wave. Let's say, for example, we are told that the middle C on a piano has a frequency of 262. Let's imagine that we are given this scenario. Middle C on a piano has a frequency of 262. If the speed of sound is 343 meters per second, we can find the wavelength. We can find the wavelength because we have the velocity and we have the frequency. We can find the wavelength by substituting velocity in case of a v and substituting frequency in terms of hertz. We can have the wavelength of this middle C, which is lambda is equals to velocity over frequency, whereby we have 343 divided 343 meters per second divided by 262 hertz. This will give us, let me check, this will give us 343 all over 262. This will give us that the wavelength is 1,31 meter. What does this say? It tells us from the starting point to the end point, the distance is 1 meter. It's 1 meter. Or from one crest to another crest, the distance is 1 meter. And the last thing we need to know is the differences between transverse wave and a longitudinal wave. What are those differences? Let us first talk about the transverse wave. In a transverse wave, oscillations are perpendicular to the direction of energy transfer. Oscillations are perpendicular to the direction of energy transfer. What does this mean? If oscillations are going up or down, direction of a wave is from left to right. That is a transverse wave. If oscillations are going up or down, direction of a wave is from left to right. And a longitudinal wave is different from transverse wave. And here is the difference. For longitudinal, oscillations are parallel to the direction of energy transfer. Oscillations are parallel to the direction of energy transfer. This is an example of longitudinal wave. This means that if oscillations are going from left to right, these are oscillations are going from left to right. Also, the direction of a wave is going from left to right. And the wave and the longitudinal wave have compressed areas. And other areas are widely spread. Widely spread. That's all for today. I hope you enjoyed this video.